Everyone's lying. North America's worst disaster is about to happen. In this day and age, climate change is a buzzword now. Young protesters are championing for a better tomorrow, yet the old leaders go unheeded to their chants. Climatology experts trying to solve the puzzle. If cracked, we could seriously limit the harm that it causes. Let's delve right into it. Over the past decade, weather patterns have seen some remarkable changes, and now before anyone thinks it's climate change, experts in Australia as well disagree on that matter. Australia is one of the major countries that sits right in the middle of altering weather changes. The country's east coast side faced major flooding and cooler summers for the past couple of years due to the infamous La Nina's winds. La Nina winds breeze cool air over the tropical Pacific Ocean, where its twin, El Nino, does vice versa. These twin cycles take turns on both ends of the central and eastern tropical Pacific, with sea surface temperatures varying between both events. Collectively, they are called ENSO, or El Nino Southern Oscillation. Fluctuating events of the twin cycles have brought about colossal ramifications on weather patterns, which were severe tropical rains and floods to one region at the same time as droughts in other regions, and the cycle shifts. Just because climatic effects and impacts of ENSO are largely felt in regions around the tropical Pacific doesn't mean they won't extend to any part of the world. They can be present, they're making ENSO the widespread force in driving the global interannual climate variability. The effects of ENSO are precipitation and temperature change significantly felt around East and Southern Africa, Southeast Asia, Western America, Australia, and Antarctica. Out of all the countries listed here, Australia is mostly affected by La Nina. In recent years, fluctuations are getting wild in Australia as the country has faced 3 La Nina winds per row, hence the flooding. Though La Nina and El Nino tend to alternate annually, with warm winds bringing from El Nino expected to follow up a single La Nina. 3 La Nina events in a row is unusual, but happened before. These unusual occurrences are recorded in the years of 1974 through 1976 and 1998 through 2001. Ninã blows colder winds from eastern and central Pacific toward eastern coast of Australia, attributed to having wet and cold conditions, whereas Nino winds cause drought in the southwest United States and Latin America. So what do these events got to do with climate change? Published research papers that study the links between events like La Nina and the regional climates in Australia detailed that emissions of greenhouse gas cause surface temperatures to rise. Furthermore, the frequency of ENSO effects could escalate in more parts of the country. After much study into La Nina in recent years, experts learned that there are more climatic forces at play. 2 such forces that determine the frequency and intensity of both rainfall and drought are southern annular mode and Indian Ocean dipole. Oscillation of dynamic sea surface temperature is the key attribute of the Indian Ocean dipole, in which western Indian Ocean becomes relatively warmer and eastern Indian Ocean becomes relatively cooler. This continuous shifting between warm and cool results in increased rainfall in cooler areas where increased drought in hotter areas. Southern annular mode is a low-frequency mode that focuses on atmospheric variability, causing change in pressure and movement of the winds towards west surrounds Antarctica. These areas are found in the lower southern hemisphere, which affects the weather system and winds in southern parts of Australia. Combining these 2 distinguished forces with La Nina converts a relatively hot and dry Western Australia into colder in order to occur rainfall. The combination of La Nina, southern annular mode, and negative Indian Ocean dipole could spell bad news in some parts of the country, thus replacing drought and warm winds, which was the result of absence of La Nina and Indian Ocean dipole. Hence, Australians would experience drought and bushfires in the near future. But this case is a double-edged sword, where more rainfall could create more plants so that when El Nino arrives, these plants could serve as fuel for large-scale bushfires in the distant future. It's the same case with global temperatures as La Nina breezes over the Pacific Ocean. One of the hottest regions of sea surface temperatures, causing global cooldown, is only temporary. Continuous greenhouse gas emissions can bring back the temperature up chiefly when El Nino comes along. As the ever-changing ENSO events are related to rise in temperature and the effects of climate change, it's important to understand the magnitude of the changes that will affect in the coming future. So that's why we go back to the past to learn how events unraveled corresponding to greenhouse gas emissions. Climatology experts quoted, "ENSO has changed but also hasn't. Quite paradoxical, but that would be transpired in the following explanations. According to empirical evidence collected by experts, The frequency of each ENSO event has risen slightly in the past 20 to 30 years. This was put in contrast with occurrences in 1850 and 1950 and even goes back to the 15th century. Report published by the Intergovernmental Panel of Climate Change, or IPCC, pointed out the increased number of intensity of El Nino events in the past 20 to 30 years is the upshot of the rising temperature of the Central Pacific Ocean. This doesn't necessarily mean humans-induced climate change, as the experts were able to track the occurrence of ENSO events as far as thousands of years ago by using paleoclimatic proxy evidence and instrumental record. Paleoclimatic proxy records the source of data that clue us in the climatic state of the Earth during a particular period in time. These were produced by looking at the growth and evolutionary traits of ice cores, tree rings, lakes and seas, and sediment deposits. Studies have shown that for the last 11,000 years, ENSO events fluctuated left and right. In other words, scientists have no clue whether changes in the ENSO event that occurred in the 1950s are peculiar or a sign of climate change. Even a computer simulation were used to predict the future ENSO events pattern, which, unfortunately, produced similar variations. The simulation ran so many times with inclusion as well as exclusion of greenhouse gas emission effects, and all of which resulted in different results. Detailed study in recent trends of ENSO events happening around the Central Pacific indicates that these events may as well be within the boundaries of normal variability. Apparently, it just seems like this mysterious working of Mother Nature is just normal and has no relation with human activities that bring about climate change and greenhouse gas emissions. The IPCC report noted the failure of finding the relation between greenhouse gas emissions and rising sea surface temperatures over the next centuries, but is sure of the fact that fluctuations of rainfall will increase prominently in the next few years. This doesn't indicate climate models do not result in changes. In fact, some models did, but some didn't. Thus, there was no consensus among models and lack of complete accuracy to predict the future weather patterns, sea surface temperatures, and ENSO events would be concerned in the future is considered. It's not the only concern when it comes to weather patterns when it has similar problems. Change in ice patterns and wind patterns result in the growth of ice sheets in and around Antarctica. Indeed, experts notice ice sheets gain in the eastern Antarctica Peninsula at the advent of the 21st century. Research is assigned by two teams, a team from University of Cambridge in the United Kingdom and another team from Canterbury University in New Zealand. Both teams found correlation between their evidence that ice sheets found on eastern and fragmented peninsula have grown prominently between 2000 and 2019. They have used satellite imagery and measurements dating back as far with the additional atmospheric and oceanic data for better calculation and understanding of Antarctica's ice sheet expansion in detail. The study was initially around a 1,400-kilometer long stretch of ice peninsula. Data shows an 85% increase in the ice shelf around Antarctica since the 2000s. Ice sheets along the coastlines have advanced significantly in 2019 when the team made an expedition to the coldest continent in the world since satellite records began observation in the 1950s. It is very rare for Antarctica to expand its ice sheets this very late in the 21st century, whether there have been recorded pattern of melting ice in the North Poles and other areas of the polar ice caps. This also exacerbated the level of incompatible results, with some experts saying ice will melt significantly, whereas other experts proclaim ice sheets will gain at the end of the current century. What's certain for now is that the ENSO events is quite a complicated concept between oceanic surface temperature and atmospheric. This event can have quite an impact on weather patterns, controlled by different factors like oceanic, wind, sea surface temperatures, greenhouse gas emissions, and other climatic factors. It is such a futile exercise to determine which one of these factors causes a different effect and how an ENSO event is unraveled, if that is even possible. The long-term effects of ENSO events over the past 1,000 years is not exactly a cakewalk to pinpoint the exact pattern, but nonetheless, passionate researchers keep on studying these events, and it is ongoing to this very day. Hope you're educated, and give us a review in the comments.